Hi there. Uh, Hi, I'm Ainsley. I'm the uh, Alpha intern for Capital, and today I'm going to be taking you through um, taking pictures like these and turning them into something like this that we can take data from and send to Minor Planet Center. So the first thing you'll notice about the pictures that we take directly with Alpha, which is our observatory here, is that it's looks cleaner, looks less staticky, but uh, there's a lot of extra fuzz or extra stuff in there that we want to be able to take out so that the computer understands which stars are really stars and which stars are just what we call hot pixels, or pixels that don't actually contain the data that we need. So our first step of this process is uh, making a flat or taking a flat, which is something that we usually do around the time that we take the pictures. Um, and that is a picture of the sky without stars, or without anything, hopefully. And uh, we can take that picture, and that helps us measure the amount of light pollution or the minor defects that we have uh, in our lens itself. And what we can do is take a whole bunch of pictures like that, take the common data from that, which is what we call a master flat, and then we take all of that extra data that's not part of the sky, or not part of the sky with stars, and take that away from our pictures that we take like this. And that will look something like this one here. Once we take our flats, we check for something called elongation, or how much the stars are stretching in our pictures from their normal circle shapes. And at this point, we've already taken them out, but uh, that can really mess up where exactly we see the star rather than actually uh, than taking just from face value the smudges saying that it might be moving fast if it's not really moving at all. After we take out all the pictures that don't help us, um, we calibrate them, or we line them all up together, and we make sure that all of these pictures, so this is one picture here, but uh, we take a whole bunch of pictures, and in those pictures we line them all up to make sure all of these extra stars are indeed extra, um, or lined up, rather. Once they are all lined up, then we can see the actual moving star, which I will show you. Pulling up, here is Tycho. It looks a little bit more old school than Prism does, but it can do the job just as well, if not better sometimes, than Prism. There we are. And we can look at those pictures. There we go. See it pulling it up. This is a pretty lengthy observation, so sometimes it takes a minute to actually pull them up. But we should be able to see it moving. Now these are the pre-processed pictures. I can also show you guys the processed pictures. Just to show what they look like from start to finish. And here is that those pictures. Now we can do what we call blinking, which is look through them really, really fast. And it might still be hard to see our little moving guy in there. So I can show you the actual processed and calibrated pictures next. What we do is we'll clear that out. Oop, there we go. And we'll go to our fully calibrated pictures. Bring those in. Now once we get something like this, once we get through all of that processing, which is done before, way, way, way before now, we can actually see Cactus moving in there. There we are. Let's zoom in a little bit for you guys, so maybe we can see him moving. Now, if you're still having trouble seeing it move in there, that's alright. I am too. Which is why Tycho itself can see stuff moving in there. So let's get our way all the way back to the top. So Tycho itself can help us find stuff inside these pictures, especially because it can look pretty grainy. And while I can't see it, the computer knows exactly where it is because it has matched all of those stars to a star database and can tell just by the pictures, not even by knowing where we are, that exactly where the picture was taken and where we were looking at in the sky. Here we go. Sorry about that, wrong one. There we go. This might take a second just to find it again. And there is our comet. Let me zoom in a little bit closer for you guys. And you can see it tracking. Now it's a little bit hard to see like this, so we can change. A little bit closer for you, and there it is. And so from this, see it tracking all the way across there. From this, we can take that data and send it to Minor Planet Center so that more astronomers like us can have that data to look at asteroids on their own, or so that we know where they are at all times. Something really, really cool about Alpha is it is already found or refound um, at least 9 uh, objects over the summer. That was before I started actually getting to work with Alpha. Uh, and So with something like this, if we were already looking at a picture, if we were already looking, not a picture, if we were already looking at an object and it saw something else in there, we can report that to Minor Planet Center too and help us find comets and asteroids that we may have quote unquote lost since, say, the 90s. Um, there we go. And now we can see it moving in there. See it a little bit better. And that dot right in the middle, that's Cacus. So the reason that it looks like there's a whole bunch of stars zooming past is because it takes a bunch of pictures uh, and stacks them on top of each other just so we can see it better. Um, so those stars aren't moving nearly as fast as it looks. Cacus is moving fast. There it is. Go back and forth. Right. So something else that we're looking at right now, it's a little bit after Cacus because we looked at Cacus in August. So something we're looking at right now, or the last week, is the green comet that's been in the news. It is comet number C 2022 E3 from the ZTF observatory. I wish it had a really cool name. Sadly, it doesn't. But that is okay because everyone is just calling it the green comet right now. And so we looked at it. This was on the 6th. There we are. And so here is a picture lined up with where it was. When we looked at it, it was in... Ooh, taking a second to load. Sorry about that. There we go. When we looked at it, it was in Auriga. Sorry about that. Auriga. And right about now, it is in Taurus, so it's around here, and it's headed south. So we are not going to be able to see it after maybe next week. I'm going to keep looking at it, and Alpha will be continuing to look at it, and I know a lot of uh, astronomy nerds, such as myself, are looking at it at their home telescopes. But we are working on getting some data and such from that. So I can pull up a couple pictures. They're all raw. I haven't had a chance to process them yet because I did take them earlier this week. But I can pull those up. So this here is a picture of the comet as we're getting some data from it. There we go. We can zoom into that. We can see it a little bit better. There it is to get in the future. But if you were to look at this with any kind of astrophotography camera or um, home telescope, you'd be able to see that bright green that everybody keeps talking about, which happens when the um, ice that is in a comet uh, melts and reacts to um, gases, and the chemicals bounce with the the sun, solar rays, and everything. Um, and then all of that filters through Earth's atmosphere and makes it look green. So unfortunately, we can't see the green, but we know it's there. um, might look something like this. Again, we see that fuzzy. We see the uh, super blurry around that, but it makes for some pretty good pictures. Um, there it is. It's a little close to that star. Now that star is, give it a minute to load. It's a little bit slow because Prism does some pretty cool stuff. And that star is Haiti in the constellation. Um, and you can see it within our pictures too, which helps us make sure that we know exactly where it is, which I find pretty cool. This one here. So if we look at these pictures, we can look at them in Tycho just like we looked at the others. Clear this out for you and load those pictures in. Now they're not nearly as processed, so uh, they're not going to be look as clean and nice as um, the pictures from Cacus are, because the Cacus pictures are completely done. But we can look at these. I can load all these in there for you. Whole bunch of them. There we go. Now this one's going to be a lot easier than than Cacus because this one is a lot bigger and a lot brighter. But there's also a lot more pictures, so it's going to take a while to load in there. And the first thing we see is that it is super hard to see. Uh, so what a lot of these processes do is it turns it from this gray gradient that we see in these pictures here and turns it more into a binary yes or no, black or white, which is what we see in this one here. So we can blink through this just like we did the last, and you see it moving. Now what you see, it's stuttering a little bit back and forth. That's what happens sometimes when we get the telescope to what's called a mount flip. Now I don't think there is a mount flip in this set of observations, but in our the night after that, you could see it a little better. This is just what happens when it's tracking or it moves with the star or comet to make sure that it can still see instead of staying in one place. So throughout the night, you'll actually see it scoot just a little bit to, you know, to the next place, to the next place, to the next place, and then it takes all these pretty pictures for us. All right. So far we've looked at how we go from, or we've talked about a bit of how we go from pictures like these to something more manageable like this to something that's even more manageable like this. And from this, we can take data and submit it to Minor Planet Center, which is my best friend. Kidding. uh, but it is super, super awesome that we at Capital get to submit data and tell Minor Planet Center about more stars in the sky. Do we have any questions from the chat or people watching at home? So I could show you guys some more of Prism as well. Some super cool stuff that Prism lets us do is plan our observations in this and actually control the telescope through Prism. Um, so this Prism is not connected to the telescope. This is in our lab, but I can walk you through how we plan our observations and make sure that we can see everything. So with something like C 2022 E3, we can do something. We can look in our sky chart. We can, in our sky chart over here, we can look at the comets and we can actually just search up this comet. There we go. And from there, we can find all this fun data about it. From our object list, we can add it to our viewing and actually see how much time it's going to be in the sky. So this one here. So we see tonight is going to be up for most of the night, all of the night rather. And then with this, we can make sure that we know that we can look at it all night. So we'll do this with each of our asteroids that we look at. Now we can pick asteroids just from our fancy globe back here, or we can look up specific ones via their numbers or their names. But each one of these fancy little red dots is... Oh, no, those aren't asteroids. Those are just items of interest. I could load the asteroids for you guys. There we go. There we go. And toward the south. All these blue dots are our asteroids. So we can find all our fancy information about them, and with the same, we can add it to our list in the same fashion. Sorry about that, messed up for a minute. There we go. Then we can look at this one's called Concordia. It is toward the south, and since an asteroid there, how silly. I know that one exists. Ah, sometimes it doesn't like the names. There we go. We look at Concordia and we see that Concordia is up for a lot less time. That's because it's closer to the horizon, so we picked it from around there. There we go. It's closer to the horizon, so it is up for less time. Something else we could use Prism for is processing, just like Tycho. So we can do a lot of the pre-processing in Prism, then we take it over to Tycho, or we can use Tycho itself. Sorry about that. I'm back. Uh, so another thing I can show you guys is how we take a picture and we make sure that we know where it is. Like I was talking about earlier, we were talking about plate solving. Um, so one reason that might be helpful for us is if we take one picture and we want to make sure that the telescope is looking at that picture. Um, so we can pull up a picture here. We can pull up a picture like this. Um, Now we have already plate solved this in the other version of uh, Prism, but I can show you guys how we do that here. And we can plate solve that. And so it looks through all of the data from minor planets that are online and the data that we've downloaded to our computer. Um, and it places all the large stars. So it'll place this one again in that constellation we were looking at earlier. Uh, and then we'll know exactly where it was. So it placed not even just that one star, but all of these stars here, so it knows where it is. And from that, we can take our, scoot that over for you guys. There we are. We can take that, take this here, and, oh, there we go. We can have it move to where it was there. We're going to move to this one here. So it'll show us where it was there, and we can have it overlay onto the map so that we know where it was and so that we know exactly what we're looking at. We can, here we go, just this one right here. Now I can minimize, oh, there we go. Oh, don't mind the computer, it's dramatic sometimes. But there we are. So it's super zoomed in. It has that one big star lined up there, as that's the only one there. And it looks like there is another asteroid in our picture, which we might be able to take data from and send that to Minor Planet Center as well. So not only did we get some awesome pictures of the beautiful, beautiful green comet here, but we might have gotten some data on another smaller comet. Or asteroid. I think that one's an asteroid. That one is named, oh, like I said, very dramatic. That one is named Lomia, which is pretty neat. And so when we took this picture, once again, it was in the constellation. I need to pull that back up. It was in the constellation Auriga, or Auriga. And this is where it was then, and this is where it is now. So you can see it's moving. It's in Taurus now, and it is moving toward Orion and out. That is pretty cool. I did not know that we were going to be able to see a second comet potentially in our pictures. We all learned something together. Uh, so I think that is all I've got for you guys today. Thanks for coming. Thanks for watching back later if you aren't on live with us today. And I hope I'll see you at the next one.